In this video, we are going to go over the definition of congruent triangles and the Triangle Congruence Theorem. The definition of congruent triangles, or CPCTC, is the shorter acronym that stands for corresponding parts of congruent triangles are congruent, says that two triangles are congruent if and only if their corresponding parts are congruent. Remember, if and only if is biconditional, so it's the hypothesis implies the conclusion and the conclusion implies the hypothesis. Let me illustrate a picture. So the corresponding parts are congruent, then the two triangles are congruent. So that's saying that this segment AB has to be congruent to this segment DE. This segment AC has to be congruent to this segment DF. And this segment BC has to be congruent to the segment EF. Not only do the sides have to be congruent, but so do the angles. This angle A is congruent to this angle D. This angle B is congruent to this angle E. And this angle C is congruent to this angle F. Two triangles are congruent if and only if their corresponding parts are congruent. And that is the definition of congruent triangles. Now let's go over the Triangle Congruence Theorem. The Triangle Congruence Theorem is very similar to the Segment Congruence Theorem and the Angle Congruence Theorem. T19 states that the congruence of triangles is reflexive, symmetric, and transitive. Let's go over reflexive first. The reflexive property would be that triangle ABC is congruent to triangle ABC. The symmetric property says that if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. The transitive property says that if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle GHI, then triangle ABC is congruent to triangle GHI. And I'm going to prove one of these properties for you. Let's go ahead and prove the symmetric property. So given triangle ABC is congruent to triangle DEF, we need to prove that triangle DEF is congruent to triangle ABC. And I'll do a paragraph proof for this. Now remember the definition of congruent triangles. If two triangles are congruent, then all of their parts are congruent. So, by the corresponding parts of congruent triangles are congruent, then angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F, segment AB is congruent to segment DE, segment BC is congruent to segment EF, and segment AC is congruent to segment DF. Now we have the parts broken up into angles and segments. So let's use the symmetric property for segments and the symmetric property for angles. So by the symmetric property of angles, angle D is congruent to angle A, angle E is congruent to angle B, angle F is congruent to angle C. Also, by the symmetric property of segments, segment DE is congruent to segment AB, segment EF is congruent to segment BC, and segment DF is congruent to segment AC. And since we have that the angles of two different triangles and the segments of two different triangles are all congruent, then, by definition of congruent triangles, the first triangle is congruent to the second triangle. Therefore, we have that triangle DEF is congruent to triangle ABC. And that is what we needed to prove, that if triangle ABC was congruent to triangle DEF, then triangle DEF was congruent to triangle ABC.